Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. My guest on the show today is Scott Simmons. He's the Chief Standards Officer at the Open Geospatial Consortium, or the OGC. And while Scott freely admits that standards are designed to be boring, this conversation is not. So I realize you probably didn't wake up this morning thinking, wow, I wish I could listen to a podcast about geospatial standards. So let me help you sort of warm up to the idea. Here are some of the things that we're going to be talking about. Geopose. So Geopose is a standard which describes the X, Y, Z, the roll, the pitch, and the yaw. So the 6 degrees of freedom of an object. And we need a standard for this because how else would we describe the position and orientation of a sensor on an arm on the International Space Station? We talk about something called GeoRSS. So this podcast, for example, is based on an RSS feed. Now, add geo to that and it gets a lot more interesting. There's something called SensorThings, which is clearly a brilliant marketing ploy to confuse people. We've got a standard called PubSub, which is for the syndication of spatial data. And to top it all off, towards the end of the episode, we talk about when the shapefile is going to die. So again, standards are designed to be boring. But this interview with Scott Simmons, the Chief Standards Officer at the OGC, is not. Hi Scott, welcome to the podcast. You are the Chief Standards Officer, which sounds amazing, right? At something called the OGC. I've recorded a podcast with Nadine before. She's the CEO of the OGC, and I'll put a link to that in the podcast. So we won't go too deep into what all the ins and outs of the OGC, but it stands for the Open Geospatial Consortium. And again, you're the Chief Standards Officer there. So welcome to the podcast. Could you just introduce yourself and help us understand what a Chief Standards Officer does?
Thanks, Daniel. Really pleased to be here. Yes, as the Chief Standards Officer in the OGC, my focus is really on assisting our members to develop standards and other practices to enable interoperability, to enable geospatial data to be accessible in a fair manner. That findable, accessible, interoperable, reusable acronym that we love and so many in our community do. That really mostly involves ensuring that we can reach consensus, that we can mostly agree, and where we disagree, we can find a way to still achieve a degree of interoperability that's satisfying for the community. The members do the heavy lifting, they do most of the work. I just try to make sure that everyone's playing to the same few sheets of music.
What does it take to be a Chief Standards Officer? Like, what kind of background do you have? How did you get in this position?
My background is really much more in a practitioner, and I think that's been very valuable for the role. I started doing geospatial because ages and ages ago, as a geologist looking for oil and gas, I had to make maps by hand. And I thought this making map by hand is for the birds. It takes forever. There's got to be a way that a computer will help me do some of my plotting, and then I'll do the really clever stuff with my fingers, but let the computer do the hard stuff and the boring stuff. And as I continued through my career, that practical application of the technology to solve problems and create maps led me into a position where I thought it was really important to help maybe standardize the way we work towards these maps. And I discovered the OGC and with time became very active as a participant. And eventually, loved it so much I joined the staff and have had this role now for about 9 years. And it's just absolutely fascinating.
Okay, so fascinating. I wasn't expecting that word. When people hear standards, they don't necessarily think this is fascinating. But what is fascinating about it?
Yeah, so you're right. I mean, standards are boring. The standard itself has to be absolutely stupefyingly dull because you can't have a surprise in a standard. If I write a novel or read a novel, let's say, I expect a few surprises along the way before I get to the end. That's not going to cut it. If you have a standard, you need it to describe something unambiguously where everyone interprets the same way, where everyone gets what they expect. And so we, by our nature, have to develop this content in a bit of, unfortunately, a bit of a dry and not super exciting end result. But the process getting there is really fun. That's Treasure Island, right? We got our state actors and our non-state actors out there on the high seas arguing with each other and trying to find their way around a problem, looking for their buried treasure. And if we're lucky enough, we get to hold our meetings every quarter on a nice tropical island covered in palm trees. And the process is really fun. The end result doesn't maybe reflect all the fun that went into it.
Okay, so that doesn't sound too bad. The idea of creating standards, if it's on a tropical island somewhere, like I'm into this. I just want to point out, you said it was boring. Standards are boring. That's and they're supposed to be boring. I just want to make it perfectly clear that boring is not the same as unimportant because I think they're important. And yeah, you're right. I totally understand why we don't want surprises in them. So the next question is like, haven't we got enough standards already? I'm looking at a page right now on the Open Geospatial Consortium, ogc.org/standards. It looks like we have a lot of standards. Why are we still working on them? Like, don't we have enough?
Yeah, that's a superb question. And there was this famous quote by Andrew Tannenbaum some years ago that the nice thing about standards is you have so many to choose from. But that's a good thing, and it reflects a couple of aspects of the world we have to work in. One is that technology is always advancing and changing. And so we have to adapt, and standards have to adapt with time. That doesn't mean you just update the standard to take advantage of some new technology that's available or some new concept. Many times you have to literally rethink the entire way you approach the problem because the technology change is so foundational. That's really important. The other important factor is that if we can do it right, each standard standardizes just enough to get the job done for which it was intended, and not so much that it becomes the one standard to rule them all approach. That becomes really difficult for the community who has to use the standard. It becomes hard for the writers, the work becomes inflexible. And so OGC and many, many other standard bodies have chosen to dissect the problem space into little solvable pieces. And if we do it right, we can string some of those little solvable pieces together, and you could use 3 or 4 standards to solve a much bigger problem set.
Okay. Yeah. So like the flexibility around this makes sense. Like hardware is constantly evolving, our needs are constantly evolving. 15 years ago, we weren't talking about reality capture in the same way and augmented reality and virtual reality as we are today. So it makes sense that, okay, we need a standard way for machines to communicate when we talk about these things. I mentioned before that it looks like we've got a lot of standards already. And we've got this big list on the OGC's website. Would you mind if I just pick some of these things at random and so we can have a chat about them?
Absolutely. I, in theory, should be really well informed on all of these since that's sort of my job.
Ooh, challenge accepted. Okay, so I'm looking at the list there. I can see the usual suspects. I can see KML, I can see GeoTIFF, GeoPackage, Web Feature Service, and Web Map Service. We've got a LAS file there. What about this thing called Geopose, for example? What does that do?
Geopose is a very newly published standard in OGC, and it came to us through interaction we've had primarily with the augmented and virtual reality community. And they were looking for a standardized approach to describe the pose of an object in some environment. The pose is that 6th degree of freedom orientation of an object, where it is in space, X, Y, Z, and how it's facing the yaw, pitch, roll, or whatever paradigm you want to use for describing all 6 of those dimensions. And so it's a standardized way to describe that, done in 3 general levels of detail so that you can do it really simply. For simple use cases, that's going to be really well suited to things like augmented and virtual reality because you're expecting the many, many objects, and that those objects need the easiest way to describe their environment, all the way out to really complex situations where you're describing the pose of an object that's a pose in an object. Like I'm standing here and I'm holding a teddy bear in my hand and I'm facing it a different way. I can describe the relationship of those poses. Really valuable, foundational, we think, to a number of other standards, and we'll see it probably integrated into other OGC standards as well as those that are evolving for the AR, VR, and even metaverse worlds now.
So if I'm understanding this correctly, so this it describes an object's in the 6 degrees of freedom, like you said, and that could be nested inside something else. If I had a sensor on an arm that was on something else that was movable, is that right? So I can nest these geoposes inside each other, almost like a parent-child relationship, to describe the relationship between different objects in terms of the way they were orientated in space.
Absolutely, and those objects can all be moving simultaneously, and so a robotic arm on a space station that's moving in orbit above the Earth has a absolute XYZ location of the station, but it's moving and rotating a little bit. The arm is moving and rotating. The little claw on the end of the arm is moving and rotating, and we can nest all of those and understand where each is and where it's pointing mathematically. But I know that doesn't sound simple, but it can be done reasonably simply.
Just out of curiosity, is like, when I think about something like Geopose, for example, it sounds like it would be a something that a sensor broadcasts. Hey, I'm here. I'm here. I'm here. Do you ever see things like this being used as an instruction for a sensor? Like, go here, put yourself in this position.
It's certainly a fitting use case. We have another standard in the list that refers to moving features and describes where these features are, how they're moving, and a little bit about their orientation. And one of the considerations emerging now is to include with the moving feature information more about the actual pose of that feature to understand where it is, but also, as you noted, to be able to tell that feature where it should be and where it should face. Currently work going on in a experiment in OGC on command and control of unstaffed aerial systems, drones and such. The same kind of thing. How do you give the instruction set that this is what I want to take a picture of on the ground? I recognize that not only is the aircraft moving and oriented in space, the sensor is probably on a gimbal and is also moving and orienting. How do I make sure they point at this place at this time?
Wow. Okay. Geopose, we're one. There's many on this list. The next one that looks interesting is something called GeoRSS.
Yeah, GeoRSS is a really clever standard. It came into OGC as a what we refer to as a community standard. It means it was developed by a community of spatial experts, all who happen to be active in OGC, but they developed it outside. And then our community said, this is really important. We need to bring it in as sort of one of our foundational standards. And what GeoRSS does is quite simply just add a geotag or a positional bit of information to entries in an RSS feed. And so your RSS feed could have a home, a position where it's being made from. It could be describing something that's occurring and have the position of that is occurring. Or if your GeoRSS or your RSS feed is coming from a robot on the surface of Mars, and it keeps sending out its feed each time it moves a little bit, it could send you a different footprint of that message.
So you mentioned something called moving features before, and GeoRSS, for example, that it sounds like there's going to be some overlap there. Is this the case with a lot of these standards?
It is. There's often overlap in some degree of functionality. There's even the occasional, almost pure overlap. We had a position a number of years ago in OGC that it is okay to have standards that have overlapping functionality because each may be doing that function in a different context. And it might be more appropriate to satisfy a function based on context. We also think that the market can help us decide which of the approaches is most valuable. Ideally, standards are being set after the market has an idea of what it wants, but sometimes until you can put it all into practice, it's hard to really get that reality. Ideally, as well, where these standards have some overlap, the people developing those standards have been communicating, seeing that overlap, and finding ways to ensure that that overlap is integratable across the standards. And we spend a lot of time doing that. That's really one of the main reasons we get together 3 times a year somewhere in the world, physically and virtually, to hash through these problems and understand the big landscape of what we're working on.
So one more thing about GeoRSS before we move on. I thought this was particularly interesting because like podcasts are based on an open RSS feed. Anybody can find this feed if you know the endpoint, and it's just the feed that keeps updating. And when I saw the geo in front of it, I thought, great. I wonder who is doing this. I wonder who is making podcasts that can only be listened to in a in a certain geographic location. Because I think that this would be amazing, right, for tours during through cities, for example, sort of self-guided tours. This would be the standard that you could use to build that on top of.
Yeah, I think that's a really clever idea. And having the geofence, if you will, the RSS is only valid inside this area, or I'm about to go someplace new. I'm giving you a box of coordinates. Can you tell me what feeds are available that refer to things inside that box?
Yeah, exactly. I think that'd be really, really cool. Okay, the next one on the list that I thought was interesting is SensorThings. Like this is an incredibly descriptive name. What does this standard do? What's it for?
I so what I just the name's clever. I like the name. It's seems a little bit lighthearted for an OGC standard, which usually has such a really long descriptive name, and some of these are super long. Sensor Things is a sensor framework for Internet of Things devices. So sensors that are part of that Internet of Things ecosystem that is very lightweight, typically limited functionality, purposely so that they don't have a very heavy footprint with respect to size and power and all of that. And the reason it's sitting in OGC is it ensures that the location of that sensor is every bit as important as the other information it's capturing. Every sensor exists in space and time. Every sensor is making observations that have a spatial component, even if they're not thinking about it. The temperature sensor inside a shipping container on the back of a truck, it is important where that container is and what the results of that those temperature measurements might be. So this is a very lightweight protocol to ensure that these positioned sensors can transmit their information in an interoperable way and that you can task them to do new things. So you can tell the sensor to do something, including when it arrives in a certain location.
Okay, so again, I think I mentioned this before, but I just want to make sure I understand that. So we're not just talking about broadcasting signals here, like I'm here, I'm doing this. This is what my pose is. I'm moving at this rate, speed, and direction. That this is also designed to receive information. So I can send information to the sensor, to the edge, and say, "Hey, do these things."
Absolutely. And so we have a what we refer to as a tasking part of the standard that tasks the sensor to do something. If it's an actuator, open the vent on the side of the building because we have a weather forecast that said the sun's going to hit that side of the building in 5 minutes. So go ahead and start letting get it equilibrating from the new hot air that's about to hit. So you can tell the sensor or the actuator what to do, and then you can receive the information, and you could have linked sensor that is measuring temperature inside and outside that flap that you're opening and closing, and use this one protocol to integrate all that information.
This is still on the same subject. I hear a lot of people talking about edge computing. So computing at on the sensor, doing computation on these sensors. I think you said before when we talked about SensorThings standard that it's supposed to be a lightweight thing because we don't want to, do too much on that edge. My understanding with edge computing is that we're going to be doing more on it. Do you see this reflected in the kinds of things people want built into the standards? Are they becoming more and more verbose? More and more complicated, more and more descriptive because we can do more and more at the edge.
Yes and no. It's yes, that because we can do more at the edge, we certainly have standards and interfaces that are able to keep that communication and that processing out towards the edge. On the flip side, we also then permit a whole lot of stuff to happen on the edge, and there eventually becomes a transmission problem. No matter how robust our edge might be, it needs to get some information back to some central source, usually, and having very lightweight standards like SensorThings with very efficient methods of transmitting information ensure that those devices and those things that are happening on the edge are communicated as efficiently as possible. And so it's always a balance to ensure that we're verbose, that we have the information that's necessary to solve the problem. But if we're going to be verbose, we better be elegant about our verbosity.
Yeah, that makes sense to me. I appreciate that. Thank you. So the next one I can see on the list, which looks interesting, I don't know if it is or not, but something called PubSub. Again, great name.
Yeah, another fun one. Now you're making me think we do have some really fun names out there. Good. All right. Makes me feel a little bit better about the marketing side of my brain. Yes, PubSub is a publish and subscribe syndication to spatial data. And so, as it would operate, any type of spatial information can be identified as something to which you can subscribe. And as an end user, if you have a subscription to that information, when it publishes an update, your subscription, the sub side, receives a notification that there has been a update to the information, and it can go everywhere from that notification model to actually direct push of information. So I subscribe to a publication. When the publication updates, I get the automated update to my information. It's a really, really powerful capability. Syndication in spatial data is not really super common yet, but I think it's going to become increasingly common in years to come as more and more data are freed and made freely available through new spatial data activities in various governments. So a very simple and clever syndication thing. There's a little bit of a GeoRSS bent to this because that's also syndication, but this is really dealing with data sets or portions of data sets that are natively spatial.
Okay, and so you're subscribing, say, hey, I want to know when change happens to this data set. And your thinking here is that this is going to be more valuable in the future when more people start to, open up their silos, quote unquote,
hmm
release the data, it'll be possible to subscribe to these feeds. And then I'm just interested in change. Thanks. I guess my pushback on this is that streaming is becoming so easy, essentially. We stream everything. So here in Denmark, everyone would used to 10 years ago would make their own base map. You'd make your own base map, and then your job was to constantly update the information in the base map and update that. It was a full-time job for people working in different municipalities. And then they centralized the whole thing, said, hey, we're going to do this once, we're going to do it over here. We're going to put a big massive hardware stack behind this, and everyone streams everything. So you just get updates as they happen. Isn't this going to end up like eating PubSub's lunch, if you know what I mean?
It's certainly a streaming model works for lot of use cases, but there's also going to be those use cases where, for business logic reasons, you cannot receive an update, but only on a certain frequency. If you have information like a safety and navigation data for the air or the water, some of those have a cycle of update, and all updates must occur precisely on that cycle. So you can't accept interim updates. You need to accept them when you are ready to publish the new information. And so there's some business logic why you wouldn't want to just take a continuous update. The other is also if you need to effectively timestamp your deliverable to a data set at a certain state in its time. I say for legal reasons. I imagine if you're a law enforcement community and you're looking at vehicle traffic information, you might want a stamp of the traffic information at a specific time. You would not want to have your source data continuously updated. So there are, I think, business reasons why this still has some logic. The other is also that maybe I just don't want to do the work to ingest the new content. I just want to be told when it's updated, and I'll choose the time to accept it. So I still think they're very good cases. It is a standard that's about to go through some update to be a bit more flexible. And I imagine we should probably talk about it in the working group whether some of the streaming aspects should be a native part of that standard or whether we handle streaming in other standards.
I could also see it as a way of avoiding a client sitting and polling a service all the time. Is there an update? Is there an update? Is there an update? And like you could reduce a lot of that server traffic just by saying, hey, I'll come and tell you when there's an update.
Sure. Very good use case. Absolutely.
So I've got one more here, and then I'd like you to choose one. There's some special criteria for the one that you need to choose. So the one I'm interested in knowing about is the time ontology in something called OWL, AWL.
So time ontology in OWL is one that OGC developed jointly with the World Wide Web Consortium, the W3C. And it is a standard that describes temporal reference systems and time in a fashion that is unambiguous and interoperable and web accessible. So there's all sorts of things about time that are far more complicated than we usually think. There are different calendar systems in use around the world between, say, Julian and Gregorian, but others. There are Unix time, there are other stamps of time, all those descriptors of time, and then a measurement in those time need to be referenceable. And again, I use the word unambiguous a lot in our conversation today, but there needs to be a way to understand exactly and precisely the reference to time you're using. A great example would be that many meteorological organizations do climate modeling and forecast modeling on a 360-day year because it's just more convenient to do math at 360 as opposed to 365, 366, depending on the year. So we need to understand those calendars. And if you have a date and time reference to a 360-day calendar, you need to understand how that relates to a real calendar we might use. So this standard helps deconflict all of those potential ways of describing time and does through this concept of linked data where you can have a register of time that anyone else on the web could access and their own time information could go back to reference owl time, as we say, to understand exactly what that time means.
Wow, we are down in the weeds now.
Man, tell me about it.
Okay, so I've picked a few of these ones. I would like you to pick one for me, please. But the rule is you've got to pick the boringest standard that you can find in this long list of standards. The one you think, ah, that one is boring. And remember, boring is not unimportant. It's just boring. Which one is it?
So cruel. Such a cruel question. The boringest standard of them all. I shouldn't say that my fellow members are going to be upset with me when I say there's a lot that can meet boringest. But I'm going to tell you, I think the most boring standard of all in here is GeoTIFF.
I did not see that coming. Okay. Why is that?
For two major reasons. One, it's really, really simple. So there's not, I don't get my Treasure Island experience. It's a pretty simple concept. You have a TIFF image and you want to make sure that it sits in the right place on the earth. And so you put a little bit of a geo wrapper around it. So I think, yeah, that's an exceptionally boring problem to solve. And yet I would argue it's maybe one of the more important problems that the community solved ever, because the whole purpose of us collecting images of our Earth from space is so that we can do something with them where those images really lie in the real world. And to be able to describe that in a fashion that anytime you get a geotiff, you know exactly where it sits on the Earth is just so critically important. The concept may be pretty boring, the standard structure, it's not exactly exciting text to read, but it's really, really important concept.
Yeah, yeah, a lot depends on the GeoTIFF standard. There's no question about that. You know what I don't see when I look through the list? And speaking of GeoTIFF, it's got a cousin called the cloud optimized GeoTIFF. I don't see that. I don't see the cloud optimized point cloud. I don't even think I can see GeoParquet. Where are these sort of streaming standards?
So these are all efforts in various degrees of evolution in our community, but some also in OGC. So at this moment, Cloud Optimized GeoTIFF, or better known as COG to most people in the cloud and spatial world, is finalizing its writing in OGC as a new standard. We expect to approve it as a standard this year. Some very clever folks in OGC membership have taken the brilliant work of the COG community, which was all encapsulated in code. You had a library to read and write cog and converted that into a standard document. So that is nearing completion in OGC and will, of course, complement GeoTIFF. Cloud Optimized Point Cloud is still being developed by its originators. Maybe at some point it might come into OGC. It's certainly something to consider. We've not done anything formal on that one yet. And there's a lot of variety in point cloud formats out there that are sort of in the mix. In fact, I think our point cloud domain working group identified more than 50 standards or specifications currently being used to describe point clouds around the world. So there's also
Wow.
some industry convergence necessary. GeoParquet is just about to start work as a formal OGC standard. We've been incubating the effort in OGC through a GitHub repository and a number of contributors. And in OGC, we do all of our standards work formally in what we refer to as a standards working group, and that is just about to stand up for GeoParquet. And then we can get to the process of finalizing the writing and publishing. And I'll add one more that actually will hit, I think, the streets tomorrow as we're talking. So it will have already, by the time I guess the podcast is broadcast, this will already be news that flat geobuff, another way to describe a vector or feature data in a cloud optimized, cloud native way that was developed external to the OGC, is being proposed to enter as a community standard. And the official request for comments on that should be available to listeners right now.
Cool. I'm glad that that's going to hopefully make its way into the OGC. I think it's been supported in the open source world for quite some time now, and I hear a lot of great things about it.
These are all really useful ways in which we can get data in a one into cloud native stores, but also access those more readily. And in fact, we've done quite a bit of experimentation over the years with things such as Flat GeoBuff and GeoParquet as another means to publish information from our APIs. And so when you integrate those cloud environments with APIs to access the information natively, these formats just do a much better job than some of our traditional approaches that are based on large flat file structures that have been around for ages.
So on a slightly different note, one of the things I don't see when I look at this long list of standards here, I don't see like a standard for metadata as well. We're constantly being told how important it is, and especially when I think about the opportunities in terms of discoverability through like the spatial temporal asset catalog stack. I think metadata is a big part of that. At least that's my understanding. But I don't see on this list a formal standard for how we produce a display and communicate metadata.
That yes, and so the industry accepted and government accepted metadata standard for most folks is published by ISO. That's known as ISO 19115. They talk in numbers. OGC talks in names.
Which is much cooler.
Yeah, I like names more than numbers, I'm gonna tell you, but my friends at ISO do a great job. The committee in ISO that developed that standard works very closely with OGC. Your fun fact of the day is both organizations were stood up in the same year. So OGC and the ISO Technical Committee 211 were formed at the same time. And from the absolute very beginning have agreed to work hand in hand on standards. ISO works more with those conceptual standards. We work more with those that are closer to the implementing community. So metadata is something that ISO manages. We in OGC are very, very active in that committee as well and contribute to the work, but they publish. We do, though, have a new effort also about to start soon, we hope, to work with DCAT, which is the sort of native document catalog for the web built by W3C. There is a version of that called GeoDCAT that's been used in Europe for some time now. And we're looking at standardizing GeoDCAT, which would allow any type of metadata, be it in ISO format or others, to be more web native and findable using traditional web approaches. So I think that's a great modernization for the entire community.
Yeah, I think that web native is really, really important. I mean, there's so much that it's pushing in that direction at the moment. Another quick question here, again, around standards, which was, following the theme of this conversation. Machine learning, I don't see any standards around that. And I guess maybe what I was thinking is perhaps there's a standard way of presenting a training data, for example, or how we analyze things. Or, yeah, I guess I was just expecting more around that, but I don't see anything.
Your psychic abilities amaze me today. So another one on upcoming work. So we have in work right now what's referred to as the training data markup language for artificial intelligence and machine learning. I'm tired after saying all that. We call it training DML or training DML for AI. It is a new standard that will be going out to public comment quite shortly in OGC, actually in about 2 to 3 weeks now. And it is an intent to provide a common descriptive language for your training and your validation data for any type of AI algorithm, not just, say, imagery, so little image chips that are used for AI for object recognition, but any kind of spatial information, feature data sets or little mini data cubes or whatever else you're using for training. The attempt here is to have a consistent descriptor so that you understand the suitability of your training data for other uses, perhaps, the nature of that training data, and so that you can compare your training data to your validation data to ensure that you are training and validating in a fairly common fashion. Otherwise, you're probably not going to understand your results. It is the outgrowth of work for a long time in OGC, almost a decade now, where we've been talking about there could be this black box that is artificial intelligence. Maybe we'll never be able to standardize what happens inside the box, inside the set of algorithms, but we can make some presumptions on the spatial nature of data that goes in and comes out, and perhaps understand some of the quality of those algorithms, the quality and accuracy of those algorithms based on spatial metrics. So that work is evolving now. We also have a what we refer to as a domain working group focused on geoinformatics and artificial intelligence. So the same type of problem space where they're looking at all the aspects of where we might use AI for doing geospatial processing and what requirements are geospecific for that work.
Just so I understand this, is this in part an effort to solve the problem of if I make a training set and I use it in my model and then I say, hey, Scott, here, take my training set to solve that sort of interoperability problem between us. So you can just take my training set if it's formatted in a standard way and plug it into your system.
Absolutely. And not just formatted, but it also has the appropriate metadata that describes how I developed the training data set, what I think it was suitable for. If it's to capture the outlines of houses in North Africa, and you hand it to me, and I can't wait to use it to capture the outlines of houses in the Amazon rainforest, I may have a problem. Your training data set may not work for my use case. And so we want to make sure that people understand the suitability or fitness for purpose of training data, not just how it was captured and how you can use it.
Yeah, that makes sense. I can see that solving a lot of problems as well. And saying like this could be a way of limiting the use cases, not just it's not fit for purpose, but I don't want you to use it for that military application, just as an example.
Absolutely, and the intent is it's we if we have a standardized approach to this that others will use, you get to make your own business rules around how you might want to consume or distribute your training data. Yes, if you want to put restrictions on what it can and cannot be used for, you should be allowed to tag your data as such.
It almost sounds like we could like look at some of the paradigms in I might regret saying this with NFTs and cryptocurrency and smart contracts when we think about making these kinds of standards.
Particularly if you look at the underpinnings of a lot of that work and distributed ledgers or blockchain technology. There's been this long set of debate since these technologies emerged in the spatial community about what their suitability might be and where we might be able to use those. Is it a way that you can attach basically a chain of custody to see where your data has moved through and who's using it and how they're using it? Or could you embed spatial information in those blockchains that tell you, where particular changes to the blockchain occurred in on the earth? And I think there's some interesting applications there as we start talking about suitability of data as well as the history of processing of data.
Going back to this list again, so we've been talking about standards. You've been generous enough to give us some really interesting background around some of these standards, especially the ones I've sort of randomly picked off the list. One thing I notice if about this list, if I click on it, there is a long list of documentation. Like in each list of documentation seems to link off to another list of documentation. So, and I understand the need for having a well documented standard. I mean, this is the whole idea behind standards. Is there ever going to be something where these are self-documenting? And like, I could be on the wrong path here, but it seems to me something like a simple web map service. So you can call that and you say, "Hey, give me a get capabilities file," and that way I can programmatically understand what is possible when I'm communicating with that standard. Is there any sort of effort going into making standards more sort of self-documenting in that manner?
Yes, we are definitely looking at that. The common complaint from any software developer is that really I have to read 1,400 pages to understand how to do this, really simple piece of an implementation. That's 3 lines of sample code buried somewhere in that document. We need to expose all of those pieces. We've got a few efforts underway. We've been many of the more modern standards, particularly if they're an API, can be documented in some type of API definition language, such as we can use Swagger, so that the content is ingestible and understandable by a software developer without having to read the document, in theory, ever. So there's efforts there. We have been undertaking another large effort to sort of explode all of our standards to their constituent parts and try to find a way to describe each of those parts as what we refer to as building blocks, little pieces of the standard that glue together and do something, and let people discover just those building blocks through a question and answer type format. And we have a demonstration one available right now for people to explore how they might want to get their data published to a map on the web and which 3 or 4 building blocks they could ingest from OGC and where they would find those without having to try to read all this document and documentation discover themselves. It's really an important objective. It's a hard thing to do, and it's hard for standards editors and writers to change the way we write these things so that they are more discoverable. So it's a lot of parallel efforts going on at the same time right now, but we have just absolutely brilliant people in membership and staff, not including me, definitely, but other brilliant people that are figuring this out.
You're talking about some sort of documentation, some sort of system that's going to help people understand the relationships between all these standards. If you broke them down to their constituent parts, like
Yes.
what bit of Geopose do I actually need? Is that what we're talking about? How does that relate to whatever else?
Absolutely. And it's it become you can imagine with this long list of standards and 29 now years of developing them, we there's a lot of complexity and potential interrelationships that maybe we haven't even seen yet. So every time we dig deeper, we find more little facets of this problem. So we're focused more on the newer standards or those that are very widely implemented. But yes, it's ultimately It would be nice if you were a brand new person to the world of standards and mapping and spatial technologies, and you came to OGC website, and with 3 clicks, you understood kind of the pieces you might need to bolt together to do your job. Because I'll tell you, it isn't 3 clicks right now.
I'm kind of surprised that this is such a problem. I'm not saying it's not important. That's not what I'm saying. And I'm not saying your work isn't valuable, but it seems to me like you should be able to, Google and find these things. They should be searchable, right? So I just can't imagine a developer, for example, starting to build their own GeoTIFF standard and then discovering GeoTIFF. Like, surely these things are findable. Surely they poke around in the communities a bit and say, well, how do people normally do this in your community? I've got this data. What does it normally look like when someone puts it through this workflow? Do you still bump into people that are having the problem of like, oh, what's a geotiff? I've got some data in a grid format. I don't know what to do with it. It's got some geospatial stuff attached to it.
I think people often are really good at finding the information. And like you said, the search engines, and you can just Google TIFF file on placed on Earth or something like that, and you will probably get driven there very quickly. I'm not going to practice it while we're talking, but I'm sure I'll get something close to GeoTIFF right away and appropriate links. And we need to continue to ensure that the way we document and publish our standards make that kind of discoverability still effective. My bigger concern in that we hear from the software community who are not geo experts is great. I got pointed to a standard and it's 140 pages that looks best on a printer, not on my computer screen. And where's the sample code? I just want you to give me a piece of sample code I can copy and paste, modify for myself, and run. And that's where we're trying to invest a lot more now, is to ensure that they don't just land on another problem, they land on something that helps them.
Yeah, that makes a lot of sense. Scott, this has been way more exciting than I expected.
Oh,
so,
good.
so I really appreciate it. But you're not going to get off that lightly. I want you to look out into the future here and tell me when you think the shapefile is going to die.
Oh, when the shapefile is going to die. The shapefile is ingrained so deeply in historic data that there's going to be a fairly long time period for those data to get migrated forward to something more modern. And shockingly and somewhat frighteningly, all the time to this day, contracts for new data collection from governments who shall remain nameless continue to specify shapefile deliveries as opposed to more modern formats or formats that offer some of the other advantages. So there's a lot that's necessary. I also would argue that a really effective replacement to the shapefile doesn't fully exist. OGC's published GeoPackage. It's a little bit more complex, covers a bit more than a shapefile. It works for it. The proponents of flat GeoBuff have found really good ways to use it as a drop-in replacement. So maybe that's getting us closer. But until we have something that's really, really simple and does one thing really well, that is, get your feature or vector data with all of the potential spatial, or coordinate reference systems enabled, it's going to take a while. So I think we're still more than a decade out before it becomes a uncommon format.
Sounds like we need a generational shift before we can say goodbye to the shapefile.
Probably so. And I think we have the issue, and this is something that comes up a lot in our discussions in OGC, is there's a legacy of what you would refer to maybe in government speak as systems of record, big software infrastructures and systems that are designed years before they're built and are built to have a 10 or 20-year life cycle. And so that's, we're now maybe ending the maintenance period for some of these that were created around the time the shapefile was first invented. And a lot of people who specify these systems maybe don't understand that there are alternatives yet. So yeah, I think it's a major issue, and I think there's probably a lot of people who would love to find a way to make it happen faster. I can't imagine it's an easy thing to support for increasingly. I mean, the software company DBase went out of business a long time ago. Kind of hard to write your DBase files without a variety of other tricks and tools out there.
Well, it'll be interesting to see what the new shapefile is, like what format is going to take over.
If I were a betting man, maybe I'd pick one, but I'm not. I don't know.
Hey, Scott, this has been amazing. Thank you very much for your time. I really appreciate it. If someone's listening to this, they want to know more about this kind of stuff, I'll include a link to this long list of file formats in the show notes of this episode. But is there anywhere else people can want to go if they want to learn more about OGC, reach out to you, or continue this conversation?
Absolutely. So be sure to contact me directly. I'm always happy to talk to anyone in the community who's interested. OGC.org has contact information for all of us. We're happy to answer questions, help guide you through what we have, and maybe connect you to like-minded people amongst our members or friends who can help you through your problems, or just make you feel better that you're also lost on an OGC page.
Thanks again for your time. Really, really enjoyed talking with you.
Great. Thank you so much, Daniel. This has been a lot of fun.
So I really hope you enjoyed that episode with Scott Simmons, Chief Standards Officer at the OGC. And there'll be some links in the show notes of this episode to where you can reach out to Scott if you want to continue the conversation or just say hi. So I've been working with the OGC for a while now to help produce podcast episodes like this. And we've produced a couple already. I'll link to those in the show notes of this episode. In particular, it's well worth listening to an interview with Nadine. She is the CEO of the OGC. She's a lovely, vibrant person, a force of nature. And as I discovered at a conference in Las Vegas last year, she really enjoys eating a lot of Nutella on her pancakes. But don't tell her that I told you that. All this to say that if you have questions about the OGC, if you're interested in the work they do, or perhaps in becoming a member, reach out to them. They are people just like us, and I'm sure they'll be happy to help answer questions or just generally point you in the right direction. Okay, that's it for me. That's it for this episode of the Mapscaping Podcast. Thank you so much for tuning in again this week. I really appreciate it. If you want to reach out to me for whatever reason, you'll find contact details at mapscaping.com. You can tweet at me, or you can find me on LinkedIn. I'd love to hear from you. Okay, I'll see you next week. Bye.